Okay, so let's talk about the shape of a function. Okay, so the shape of a function, right, it can either be considered concave up or concave down. Okay, so concave down would have a shape kind of looking like this, where it looks like an upside down parabola. So we consider this concave down. Now concave up, it would look like a parabola, kind of like a happy face that's opening up. Right, we consider this concave up. Right, so whenever we're talking about concave up or concave down, we're talking about the concavity of the function. Okay, now, so the important thing you need to remember is anytime a question deals with concave up, concave down, or concavity, that means that, all right, you need to find the second derivative of the function. Okay, so just remember that concave up and concave down deals with the second derivative. Okay, now let's take a look at an example right here. So we have this function and the graph of the function. So let me explain what concavity is, right? So basically, you notice this shape right here. It's concave down, right, up to about this point right here. Then starting from this point, it changes concavity, and then it becomes concave up. Okay, so this part of the graph right here would be concave down. So I'll just write C dot down here for concave down. And then this part of the graph over here would be, all right, concave up. Okay, and this point right here where it changes concavity, so this point right here on the graph where it changes concavity from concave down to concave up, there's a name for this point. This is called a point of inflection, or inflection point. Right, point of inflection. So if you're dealing with an IB question that's talking about inflection point or point of inflection, you have to also realize, okay, they're talking about where there's a change in concavity. So where there's a change in concavity deals with second derivative, right? So the key words are, you know, concave up, concave down, inflection point, point of inflection. Whenever you see these key words, you have to remember that, okay, this problem, this question right now is dealing with the second derivative. Okay? Okay, so let's take a look at this example here. So we need to find the intervals where the curve is concave up or concave down, right? So basically, when is this function concave up or concave down, right? So whenever you see these keywords, concave up, concave down, you have to remember that, okay, this problem deals with the second derivative, right? So this means I need to find the second derivative of the function. So let's find the first derivative. Y is equal to, that would give us 6x squared minus 6x plus 4, right? That's the first derivative. So the second derivative, we're going to end up with y double prime, or the second derivative, is equal to, we have 12x minus 6, right? Now, once you find the second derivative, you want to set it equal to 0. So we have 0 is equal to, right, 12x minus 6. So if you add 6 to the other side, we're going to get 12x divided by 12. So we get 1/2 is equal to x. Okay, so once you find this x value, what you want to do next is make a sign diagram. Okay, so we're going to make a sign diagram, all right, for the second derivative, right? So this is a sign diagram for the second derivative, right? Or actually, let me put y here since we're using the y value. For the second derivative, and then we have 1/2. So this value 1/2, this is the x value, right, where the second derivative will equal 0. Okay, now what we need to do is we need to test to the left and to the right of this value. So to the left, I can test, let's say the value is 0, right, if x is equal to 0, right? So let's say if x is equal to 0, right, so I could plug it in right here. I would get basically 0 minus 6, so I end up with negative. Over here, I can test the value x is equal to 1. So if I plug in 1 here, I would end up with 12 minus 6. I end up with a positive value. So that means that to the left of 1/2, right, it would be concave down. And to the right of 1/2, it would be concave up. Okay? Now to make sense of this, right, so when is it concave down? So basically it would be concave down when x is less than 1/2, and then it'll be concave up when x is greater than 1/2, right? Now to make sense of this, let's take a look at the graph for this. Okay, so here's the actual graph for the function or in the example we just did, okay? Now remember our sign diagram for the second derivative, right? So the sign diagram for the second derivative. So remember at 1/2. So here's 2, right? Here's 1. So 1/2 is this right here. So basically right here, right? So right here, 1/2. And then remember, this was negative to the left and positive to the right. So you notice, I want you to make sense of what's going on right here. So remember, this represents negative is concave down, right? So concave down, and then positive represents concave up. So concave up. So if you take a look at the graph, you see how right here, this is concave down, right? Remember, concave down kind of looks like this shape. So it's just not completely filling this shape. So it's concave down, and then when it gets to this point right here, right? So this point right here, it changes shape to concave up. Okay? So when you found the second derivative and you set it equal to 0, right? When you find that x value of 1/2, I want you to understand that what that means is this is the x value and this is of the point, right, where the graph changes concavity. So you notice right at this value where x is 1/2, right, it changes from concave down to concave up. Okay, so when you're finding this value, it's important to understand what it actually represents graphically so you can make sense of the problem. Okay.